3 would go to the top. Why is object 3 going to the top? Object 3 went to the top because it's less dense. Everybody remember that? Okay, so that means who's going to be in the middle? Object 1. Everybody okay with those concepts?
Yes.
Okay, so number 2. How do we find the density of a block of wood? Density equals mass over volume. All right, so the question says, what is density? So I'm looking for which of those letters? The D, right? So what's my mass in the question, the M or the V? The D, the M, or the V? I'm looking for D, so I got to have M or V, right? So one of those two numbers is my mass. Which one of the two is the mass? Okay, that gram right there tells us this is the mass. That's why we spent all that time learning the units. Because I'm looking for D, or density. I know it doesn't go there. So it either has to be M or V. Do you see how I made that leap? For those of you who are struggling? Okay. So that gram right there is my mass. So I'm going to put 10.5 where the M is. That means the other number has to be my what? My volume. So I'm going to put it on the bottom. Now, how do I solve for that? What do I do to get the answer? Is D by itself or is it with another number? Is the D right here by itself or with another number? Is by itself. If it's by itself, we don't have to cross multiply. Okay? We only have to cross multiply if the number is with something else. Does that make sense? Okay, so since it's by itself, we don't actually have to cross multiply. So all we have to do here is what? Divide. Logan, William, stop. So take a calculator if you didn't get one. Get one in a little bit. 10.5 divide 4.25, and we get 2.47. Take my nice scientific buddy there. 2.47. You can just round off. Again, no more than 2 places behind the decimal. Now, what can you tell me about the 2 units? Do they have anything in common? Do the units have anything in common? So are we going to cancel anything out? So what did you write on your lab sheet yesterday when they didn't have anything in common? Gram slash the milliliters. You're going to write gram slash the milliliters. Okay? Now, if the block is divided in half, what happens to the density of the block? It stays the same. Okay? Now, we did this on the worksheet the other day. Some of you probably forgot that. But if I take that 10.5 grams and I cut it in half, what's left of our mass? Okay? If I take 10.5 and I divide it in half, I get 5.25, right? So this side is 5.25 and this side is 5.25. If I take my volume and I divide it in half, I can probably do it in my head, but let's not make a math error. 2.125 and 2.125. Now what do I do with those two numbers? If that's my mass and that's my volume, what do I do with them? You divide them. And when you divide them, you get 2.47 on this side and 2.47 on that side. So is the density different? Stays the same. Okay? So it doesn't matter if you cut it in half. So why does it stay the same? Did the material change? No, it stayed the same. So yesterday when you guys found the density of water, should your densities have been different or should they have been the same? They should have been the same. Now, were they all the same? I don't know. Pull out your lab sheets. Let's see. Let's see what you came up with. See how close you came. Hopefully they're close. We're going to finish it. Well, the only thing we're finishing are the questions. The data you should already have done. If all you got are questions, I'm going to give you time to do some questions. But I'm not giving you time to do the data. Data has to be done. All right, so look at part A. Look at your density. All right, what'd you get? Give me a number. Somebody yell out what they got. What?
110.
Something else. What, Damien? Look at part A. 0.96? 97? What? 0.96? Anybody else? Brave, want to tell me what y'all got? I should have had like 10 groups. It's only 3 answers. Logan, what's your group got? What, 1.08?
I got 1.04.
What did you say? Maybe I misheard you.
The density.
The density of the water. You got 0.8? Okay. 0.8. Anybody else? And Luce, what'd you get? 1.09? Nathaniel, what's your group have? Just part A. All right, do you see a pattern? What's the answer pretty close to? Density of water is around 1. It's actually 0.998 grams per milliliter. The biggest number we have is 1.1. The lowest number we have is 0.8. Okay, but they're all in the same range. All right, now if I ask you zinc, zinc is going to vary quite a bit. You want to see? All right, tell me what you got, because y'all's lab technique's not going to be very good. All right, 6.4, 6 point what?
2.
6.8. 6.3.
I got 7.0.
Anybody else? Want to be brave? Tell me what you got. Really? What'd you get, Roy? Since Nathaniel won't tell me without asking you first. Damien, what'd y'all get? Virginia? Oh, you already told me? Alexis, what'd y'all get? Should you tell me?
William already.
Chase, what'd y'all get? Okay. Raul, what'd y'all get? All right. Let's see what the answer is, because I don't know that off the top of my head. That's the right answer. Okay? It's not that. It's not bad. Okay? Not terrible. Okay? Now, what'd you get for the wood? That one usually varies a lot.
I got 0.
0.6? 0.6? What? 1.03? Anybody else want to be brave? 1.86. So now we've got a 0.6, a 1.0. What did you say, Virginia?
3.
A 1.8.
C.
Anybody else? So with the wood, we're starting to run off the rails because that's varying a whole lot. What? 3.8. Okay. At the wood, we've run off the rails. Hopefully with the Play-Doh, we've come back on the rails. Nathaniel? 3.7. Now, does wood sink or float in water?
That flows.
If that wood block's going to float, it should be less than 1. That would have been the closest out of all of them. It's actually around 0.5. Okay? Now, as long as you have your stuff written down and you got your units, I'm not going to mark it wrong. Now, the parts that we need to finish on our lab sheet, okay? Now, when you look at your lab sheets, you should have data in all the parts. Now, if you did not finish all the parts, good God almighty, y'all don't even have part D done. I did.
Yeah.
Now, if you're Alexis and you're a group like Alexis, y'all need to come see me next week. I'm free every third lunch. I know. Okay. Now, if you're Alexis and you're busy, you work. I'm free every day third lunch. If you want to finish your lab during lunch, I'll be glad to help you during lunch. I have no idea why you've got an entire section with blank. All right, but we need to get that done. The rest of you should not have giant sections like that of blank. Anybody else got a whole section of blank? Other than her group.
The back.
I got 2 groups that are blank in a whole group. Again, I'll be here during lunch.
The back.
Now, the rest of us should just have questions, which is what I was hoping to have to do today. Now, 1, 2, and 3, you should be able to answer without help from me. Those are just basic questions. And if you listen to what we just talked about, you should now be able to answer question 1. Okay? 2 and 3 are basic calculations we've been reviewing for the last 2 days. So we need to talk about questions 4, 5, and 6. All right? So let's talk about those. Now, on your graph. Oops, that's not what I meant to do. You got a hunk of graph paper there. I want the entire piece of graph paper to be quadrant 1. Do not draw a giant coordinate plane there. It tells you in the directions that what is going on the y-axis. Mass. So over here on the y-axis, write mass. On the x-axis, write volume then. Now, I want you to label and count by 2s. Because question 5 tells you got to count something up to 45 grams. Do not skip lines and number by 2s. So forth all the way down both x and y axes. Count by 2s. 2, 4, 6, 8 till you get to the top of x and y. I probably need to get rulers back out. All right, you got it numbered? All right, so these are the points you're going to plot. Everybody got numbers? So, look at your data table in D, okay? The first point you're going to plot is whatever mass that you have written right here. All right, this mass and this volume. It's like your X, your X and Y, okay, like from math class. So you're just going to find that, okay? Can't make that little line go away. So X and Y, and you're going to plot it. You're going to come back over here, go up for your mass, over for your volume, and plot your point, okay? Everybody okay with that? Anybody need me to come out there and help you find the mass and the volume? Sacramento, you got it? Any help? Or did you not get to that part yesterday? You were here yesterday? No, that's all you know. Okay. Oh, by the way, since I'm thinking about that, since Sacramento was not here yesterday, he didn't do the lab. When I grade this weekend, how will I put his homework grade in for yesterday, and how will I put his lab grade in? Last year, we would have put in NHI for not handed in, right? When we went to Power Teacher Pro this year, it doesn't have a code like not handed in or NHI. So how do I have to put it in this year? I put it in 0. Now, I mark it as absent and missing. So it should come up when you look at it. In mine, it's colored with an orange block and a green block for absent and missing. Okay? But I have to put in the 0 so you know that it's averaging and your average is a 0. Because if I don't put in a grade and I leave it as a blank spot, you assume your average is much higher than it is. Okay? And I'm not going back 2 weeks before the end of the semester and average putting in all these zeros, and then you go, well, dang, I had a B this wall and I got an F. Okay? I want you to know up front. If I don't have that assignment, my average is down here at the top. Okay? But I will mark it as absent and missing so you know that that 0 can be what? Made up for full credit. Okay? You turn in late homework, I put a 75 and I mark it as late. So you know that's why it was a 75. I put all those codes in Power School so you know what those assignments were graded as. All right. So the next assignment, we're going to sample 2 for mass and volume 2 right here. We're finding that point. Okay? And then we're coming over here. It's probably not going to be at the same point. It might be over here somewhere. Might be down here. And then we're going to do the same thing with mass 3 and the last volume. And we're going to put its point on there. Okay? Now, the thing you're probably going to notice is, are those dots in a straight line on your paper? Most people's dots are not in a straight line. Now, ideally, they'd be in a straight line. That's great. That means your lab technique was pretty good. Okay? Most people in physical science, lab technique's not that hot. It's not a straight line. That's why I got the rulers out. Okay? What I want you to do, I'm going to use the meter stick, is I want you to take a ruler and I want you to lay it down from the origin. You know where the origin is, right? And I want you to make the best straight line you can. If it goes through 2 dots, great. If it doesn't, okay. Draw the best straight line you can. If you got to just shoot for in the middle of all 3 lines, draw a straight line. Draw a straight line through your graph as best you can all the way through there, okay? So since I have 2 lines that are close together, I'm going to say like that. Only I'm going to have done it with a ruler so it looks straight, okay? Now, when I get to question 5, it says read 45 grams and give you the volume, right? So I'm going to find my 45 grams right here. I want to know the volume. So how do I find the volume at 45 grams? I'm going to where the 45 grams is, and I'm going to read over and then I'm going to read down, and I'm going to find whatever that volume is, and I've got my answer. Okay? When I get to number 6, it says find the density. Density is mass over volume. What do they tell me the volume is in number 6? Okay, question 6.
3.
It's 3, right? But they don't tell me the mass. So I got to find my volume of 3 here, read up to the line, and read over and find my mass. Depending on your line, your mass is going to be different. This is where each person has to read their own graph because you drew your points on. So I'm going to say Virginia and Sierra, who I know work together, they drew their graph. Is their graph going to necessarily look the same? No. So you have to read your own graph to make sure your volume in number 5 and your density in number 6 match your graph, okay? Not your partner's graph. And I'll wander around for about 10 minutes and make sure everybody's okay. Okay, so draw your line and answer 5 and 6, and then your lab should be done. Other than my 2 groups who got to finish their data. Unless you just want to turn it in as is, which you can do also. But if you're never going to stay to finish the lab, at least turn it in with what you have done. Don't not turn it in ever. All right, come on. Finish your points. Grab a ruler. Rulers are on my desk if you need it to draw a straight line. And then answer the 2 questions. I will be here next Wednesday if you want to work Wednesday. Or you can always do lunch if you want to do a couple days during lunch. I mean, you missed the lab that we worked on for over an hour. So you choose. Or you can just keep 0. I mean, it's your option. But, you know, you don't want to keep 0. I mean, you strike me as pretty smart. You know what I'm saying? Okay, you can work with your partner. You just got to make sure you read your own graph to get the answer. Yeah, the problem you got is y'all have all the D missing. None of them data from D. Because you don't have any of this stuff, you can't do what we're doing right now. You can answer 1, 2, and 3. Because we've done enough to do 1, 2, and 3. But y'all have to come get your data for this part. You can either do it during lunch or I'll be here next Wednesday after school. That's fine. I mean, I will be here. Yeah. Yes, you'll write your name down. Take the pass.
Yeah, you can go out there.
Yes.
And I ain't using Miss Walker. I use it after that because I'm gonna need it for But she said ours. Because I ain't put the space enough to sit. So she said that's why I did it.
The equipment's right there. Just gotta grab the plate on the table.
After we find the volume, we do the D.
Yeah, then you do the D equals M over V. So read your 3 milliliters, find your mass, and then plug it in.
You want to do it?
Sure, given you got those 2 points right there, I'd probably shoot for yours, probably along there, and ignore that one.
We already got it.
Anybody else? Huh? Yeah, put it in the chair up there in front if you're done. Up there with the orange jacket on it. Yeah.
I keep saying Miss
Miss my name's not, you know, there's 4 of them in here. And they're easy to remember. Yeah. Yeah, you say during lunch any day. And I'll be here Wednesday after school, but you can do lunch any day. Until it gets turned in, yes, I will. I mean, not until I grade it. I'll do it whenever I grade every month. I don't grade it till next Tuesday. It won't go this day until I grade it. And I'm gonna try to do it this weekend, but I won't be in town Saturday or Sunday. Depends on if I decide to grade it while I'm driving. A lot of times I do it on my weekend. Go see this class. You know who this class is? You know what guidance is? directly across the hallway of that into the offices. She's over there. Okay, and they can direct you to her if you don't know her. She's the white lady who's over there. She's the Miss Whiteside, who's the social worker. I think Mr. Kim who's over there now.
He's,
Kendra,
my side.
as a glass. She's the office on the left.
No.
Okay. Yeah. But she's real helpful with the
I'll
county.
get you. Oh, yeah.
No, but parents is hurting my wrist. I can't move it. Just hurts. Sure.
We use that.
Huh? The only thing they could do when I kind of broke it and then got something, they did give me a shot in the rear end for, they didn't prescribe anything, pain. They don't give drugs anymore for pain, so it didn't matter that I broke my wrist. They don't take Advil. The fence that you see there on that side and on that side serve the same purpose as that, but it's still required by law to be in a classroom, in a chemistry lab. Eventually, I think that will be phased out and you won't need them anymore, because when I turn the hoods on, it recirculates the air every 20 minutes. Changes out the entire air in the room every 20 minutes. Yes, ma'am.
So for 6, we only put centimeters cube right for the unit.
No, it's a, so you got a gram and you got a, all right, now that was match, right?
Yeah.
So that has to go there.
But it says determine the density of
That's
the.
right, so you're looking for the D. The D is here. All right? Pulse. Over, what was your mass that you read?
5.
So you put 5 here.
No, I had it right the first
Okay, 16.4. All right, hold on, go back to your number. You skip lines over.
Don't do it. Don't skip on.
So you have no way to 45 here.
I did skip on the first time.
You gotta go back and renumber. See how Bree didn't skip lines? So she can get to 45 over here. You have no way to get to 45. So renumber so you're not skipping lines in the right place.
If ever makes any sense, you have to make it.
Yeah. I'll be right back. Look at on, Logan, are you done? You're just standing there shooting the breeze about the football game.
Wait, I'm getting right to bring up every number.
Yes, sir. Okay. All right, take your ruler. And given where they're at, I would probably take mine and you can probably get pretty close to like these two right here. So I would like that. Okay, and now answer the 2 questions. So find your 45, which you're going to need to finish numbering. And then you can read over to the line and read down and find your volume, which is question 5. Okay? So you got 30, you got a number up to 45 grams. Question 5 says, determine the volume of the sample at 45 grams. Yep. You'll be back. No, Sacramento. No. Yeah, so I've got to get a big, like, tube sock and fill it with rice so I can heat it in the microwave and wrap my hand in for 10 minutes to soften the tissue. And then I have to massage it so it works slowing out every couple times a day. But we didn't have any long socks in the house last night, so I had to put searching for long socks tonight. Yeah, it's not more tube socks in the game. Okay, so I put a unit on it. Found volumes. Good. And now the last one. You're doing what I did there, number 6. Density equals mass divided by volume. Okay, so I put the volume there because that's what they told you have. Now you got to read your graph. Find 3 milliliters, read to the graph, and then find the mass. Okay. So 3 milliliters would be where? All right, read to your graph and read over to you again. Okay, so plug in the 4 where the mass is, show the word, and get your answer. You're done. All right, what you got? John, you got it? Nathaniel, what about you, Roy? All right, what you got? You going in the dots?
I have school.
Okay.
So when you put it in the bottom.
You got 742. Your volume's not big. All right, so you got 7.2.
Yeah. Well,
I know.
that's basically. Yeah, for next one. I'm talking about just radio. Yeah.
I got you. I'm going like that.
That's where the army, that's where they go. Yeah.
You need to finish that. No, get it done. You're almost there. Logan, wait, sit down. All right, now what you got now? So if we do 16.4 and 14, 16.4 over 14. So Do the other big ones.
You got it.
Back to it. You finished?
And then the summer,
You gotta show me the calculations. You got mass, you got volume, calculate density. D equals M over B. Put it on the chair. I mean, you can just leave it blank out there, points off, but that's even dumb. You can leave it, you got a calculator right there. What doesn't work? Calculator? Really? That's lame.
Oh, he brought 250,000 in yesterday.
Oh, he did?
Yeah.
I wondered why I didn't bring your favorite towels.
Oh, yeah.
I'm glad you told me that, but it never occurred to me. John, finish. I already yelled at this, John. You two work together? Really, finish. All you have to do is calculate density if y'all work together, because that's all he's got left. Yeah, put on that, there's a stack of them behind the computer, right up there. All right, you got it? All right, so, where they're at. All right, Bree. We're gonna do the last three. We're gonna read the last two questions. All right, so I've got about 5 people finishing up, and then we should be good.
Did you read this? There.
It's okay. Your graph may not look the same. It's okay. That's why I said you got to look at your graph, not your partner's graph.
What you gonna do is that's your volume, so that's you gonna do
All right. If you're not done at this point, you're going to need to finish on your own. Okay? So, if you are finished, bring it up, put it on my desk. This is a paltry number of lab papers, but if you finish it, set it on my computer up here, turn it in. If you have not finished, or you were absent, whose responsibility is it to get it turned in? It's y'all's. Now, okay, fill in the parts, get it turned in. If you're not ever going to finish the parts, turn in what you have, okay? Because at least you can get what you got graded. Oh, right there. Put your name on it. Now, we're going to move on and talk about motion for the rest of class. We're going to talk about our new topic. Okay? I'm going to save the density review sheet for Tuesday so that you have a refresher before we take the test on Wednesday. I'm going to just bump that till Tuesday so we've got something to review with. All right, we're going to talk motion for the rest of class, which is a new topic. Now, if you remember, that's not what I meant to open. If you remember physical science from middle school, depending on, I don't know, what grade they taught it in, they would have taught you speed, velocity, and acceleration, possibly.
That was in the 7th grade.
Okay. I would have thought they would have covered this. That's why I was asking. Now, I don't know how much they would have done, depending on, and you'll hear me say this often, depending on your experience. Some of you got more, some of you got less. Now, it's often true at the middle school that some of you have a sub for science class in the middle school, while some of you have real teachers. Some of you got, unfortunately, that experience. Yeah. Are any of y'all had that experience?
Yes.
Yes.
Unfortunately. Okay. So hopefully that didn't happen very often in your science career, but sometimes it happens. So I just assume over the course of our time together that some of you had terrible experiences, and so I tend to teach it all. So if you've had it all and you're like, well, I keep going back over this, that's why. Because not everyone had the same experience. Some of you had a fabulous 7th and 8th grade experience because you did not have the sub. You got the qualified teacher. But unfortunately, some of your classmates in here got the sub. So we're just going to assume that you all had the sub so that everyone has what they need. Go ahead, Jay. So what is a frame of reference? In order to talk about motion, we have to understand the concept of a frame of reference. Once we understand that, we can talk about any type of motion. And then we're going to look at distance and displacement today. Those are the only two concepts we're going to do. I think I told chemistry this, but I don't think I told y'all this. Typically, there's an agenda on the board that I stick to during the course of the day. Sometimes I'll flip things out, like I took out the review piece. But I have to stand on a step stool to write that because they put all the control buttons for the room on the wall. But I've fallen twice this summer, once off the sidewalk and broke my wrist in 2 places. So I promised my husband I would not stand on the steps and take a chance I would fall off, particularly given I have to use this hand to hold on to the wall. So as soon as I have fully functional hands again and I can do that, I'll have an agenda on the whiteboard again. But it might be a few weeks before we have that. So what is a frame of reference? A frame of reference is a stationary object or one that appears stationary in order to determine if another is moving. Now, I've actually answered the question that's below it, and below the blind. All right, a frame of reference is a stationary object or one that appears stationary in order to determine if another is moving. John, pick your head up. And then insulting. I'm usually pretty good at my job. I like to feel like people are interested in what I have to say. Now, why do we need a frame of reference? Why am I talking about it? Aside from the fact y'all want high school credits and get out of here.
In order to determine if
That's right. Okay? It tells us if an object is moving. Do I appear to be moved?
Yes.
Okay? Then that means there has to be something in here that's not moving. So, what is the frame of reference? You could certainly use the desk as a frame of reference. The what? The wall. The wall can be a frame of reference. The floor can be a frame of reference. Now, you could say the school building. Okay? There's nothing wrong with saying the school building. Okay? Now, generally speaking, we tend to use large objects.
that does,
Hmm?
that big does
The big desk can work too.
us.
Now, hold on with that. That's where I was going with this. Let people catch up with you. Let me see what I have right here. Okay. Because I'm not going to use that. I don't want that giant description thing.
Chair.
All right, we caught up? All right, so let's say, all right, is our example. This wall walks around the room. All right, things you said were the frame of reference. You said wall. You said chair. You said building. Did I forget anything?
Us.
All right. People. All right. Why would I say no to people? Bring it back up here and hang it on the hook like this. Why would I say no to the people?
That's what just moved.
Because you guys are also likely to do what? Y'all are likely to move. If I look at William right now, what's William doing? He's moving. He's eating something off that paper towel, writing in his notebook. He's going to set his leg down. He's also moving. Is the chair moving? No. Okay. Is the building moving? Is this table here moving? No. So what?
So give me quiet. I've said it again.
Okay. Now, assuming Logan's quiet. All right. The other objects are stationary. All right. Or they appear stationary. Now, if we were to go outside, all right, and we used an example such as, all right, who's got the driver's license and here and drives? Who's got their driver's license and drives? All right. So we got Damien over there. All right. All right. Damien's driving down the street. All right. What's the frame of reference? Okay. pole,
Tree.
tree,
Oh,
okay, the road itself.
hold on, the trees move when the wind blows.
Okay, we'll put tree trunk.
Clouds.
All right, clouds is an answer we often get.
There are
Clouds move, okay? They move and they change shape all the time. So you don't want to use clouds as a frame of reference when you're outside, okay? What else can we use as a frame of reference when you're outside? Houses,
Heart cards.
sure. Now, would you want to use moving cars?
No.
No, okay? Have you ever been in a car and had the sensation when you were sitting at a stoplight that you were moving?
Yes.
Yes, I've had it all the time. And if you've been driving, sometimes I question myself, have I taken my foot off the brake? And I haven't, but the car beside me was moving, okay? So I don't usually use cars that are sitting in the lane of travel beside me either. I want parked cars for my frame of reference because you can have the sensation that you're moving and you're not, okay? That's a frame of reference. Now, in reality, are we actually stationary? We're sitting on the what? We're sitting on the what? Starts with an E.
Earth.
The earth. Is the earth stationary?
No.
No, we're moving all the time, right? That's why back here in the definition, I said we had to appear stationary. I was wondering if anybody would argue with me on that definition a little while ago. So, all of these things that y'all gave me, tree trunk, and all that, were attached to the earth. So you could have said the earth as the frame of reference. Now, when we talk about the earth is moving, right? What is its frame of reference?
Sun.
Yes.
The moon.
You can say the sun. You could even really say the moon. Okay, if the moon is out. Okay, because you can see either one of those. Questions about what a frame of reference is? Now, if y'all ride buses in the afternoon, okay? If you're on a bus, okay, and you're looking inside the bus only, can the bus itself be the frame of reference?
Yes.
Sure. Let's say you're just looking inside of the bus and someone's throwing a ball back and forth on the bus. Not that anybody should be doing that. All right, but let's say you have a rowdy bus driver's not paying any attention, and you're throwing a ball back and forth on the bus, but you're looking in the bus and not out. What could be the frame of reference inside the bus? The seats,
The back.
the floor or the aisle of the bus, the ceiling, any of that could be the frame of reference, okay? All right, let me have somebody who's going to be my passer outer today.
Community service.
Oh my God. Here goes the
Huh?
Here goes the invisible.
All right. All right, so I want you to look at those examples, and I want you to see if you can figure out what the frame of reference is. If there's somebody close by that you want to talk to about what the frame of reference is, you can. The frame of reference does not have to be stated explicitly in the example. Okay? It does not have to be something you can circle. If you can figure out what it is. And it can be more than one frame of reference also. It'll take about 5 minutes to figure out what they are, and then we're going to talk about them. Are we done? Any more time? Where are we at? Let's see, we have that. All right. Since y'all aren't talking, don't even talk to me. All right, number one. The sun rises over the horizon. What would you tell me the frame of reference is?
I said sky.
All right. Not crazy about the sky.
But
It's the horizon.
All right, the horizon I like, and I like another one I heard too.
ground.
The earth, Raul, I like that one too. I like the earth and I like horizon. Okay? Because the horizon is essentially the earth. The sun is coming up over those two things. All right, for B. All right, a bus moves past people standing on the sidewalk. There are multiple things you can tell me here. Sidewalk is what most people tell me because it's in the question itself of the exam.
The road,
All right, the road would be fine.
build a hole.
Buildings, poles, any of that. But most people say sidewalk because that's what's in the question, because the sidewalk is not moving. All right? A passenger on a train sees a ball roll down the aisle.
I,
All right, most people say the aisle because that's what's in there. But you're on a train. What things are on a train? Y'all may not have been on a train, but it's just like a bus. What things are on an aisle on a bus? Seats could have been the answer. What else? Ceiling, the walls. What?
the fire
But
exit.
we put the luggage out.
Yeah, the compartment where you put the luggage at. All those are fine. All right, indeed. Two express subway trains traveling at the same speed on parallel tracks whiz past passengers waiting on a platform at a local station.
Platform.
Platform is what most people say.
Track.
Tracks are fine.
Station.
The station is fine. Any of those are good answers. All of those things are stationary. They're not going to move. In E, a passenger on one of the subway trains looks out the window and sees another train standing still.
Window.
Okay? You could say the train that is doing what?
Standing still.
Standing still is fine.
The window.
The window where? On which train? The one that's standing still would be okay. That one that's parked, you can say that window, but the train that's moving, can you say that window is the frame of reference? No, it has to be the train that's standing still. Now, what else could you have picked? Sure, the tracks could have been the frame of reference. Again, you could also have picked the. Never mind, it doesn't say anything about the train platform thing either. All right, a person standing near a railroad track sees a train pass by, then notices an airplane fly overhead in the same direction as the train, but at a much faster speed.
Right.
All right, I hear track. Yes, no.
Trees.
All right, Jacob's going out on the limb here and just leaving the question altogether, going with trees. You like his answer?
Yeah, I like trees.
Trees are fine. Where are the trees at?
I don't know, there's somewhere on the earth.
They're attached to the earth. The earth is, you could have said the earth is an answer. Trees are fine. Track is fine.
Everything that's not moving.
Everything that's not moving is fine. The plane is moving. You can't pick the plane. The train is moving. You can't pick the train. What things are not moving? When you look up at the plane's moving. What is not moving when you look up at the plane? Okay, you're going to pick the sun.
Earth.
The earth is not moving. The sun is not moving. The trees are not moving. The track is not moving. You can't pick the train because it was doing what? The train was moving. The airplane was moving. So the other stuff, if there was a giant boulder sitting out there, you could have picked it too. Say what? Don't pick it if it's wrong.
I could take it that far.
Really? He's going to be the irritating one in the class, isn't he?
Yeah.
The boulder was rolling. Okay. All right. G, a passenger in the airplane looks down and sees the train moving backward. All right. So what can we pick there? If we are, any of y'all ever flown before?
Yeah,
Okay. So you look out of the airplane window.
it's creepy.
It is a little creepy. What could we say is the frame of reference if we look out an airplane window?
Buildings.
All right. Buildings, the earth,
Lights.
lights,
Ground.
the ground.
Bro, your cities look so.
Okay, anything that you see that's not moving could be the frame of reference. Now, just saying the ground is not very specific, so you want to find some object you can identify. So those of you who have flown, when you look out, you can usually identify things when you go into big cities like football stadiums, large buildings.
Baseball stadium.
If you've flown into a capital such as DC, you can usually identify the monuments, but you can identify
You can't fly.
large features. Okay? Say what?
You can't fly over the White House. So.
No, you can't fly over the White House. You can identify Washington's Monument, Jefferson, Lincoln, things like that.
I said they might stop legal flood.
You can't fly over the White House. You are correct. All right. Questions about that?
Shut down.
But you're basically just looking for something that's not doing what? It's not moving. That's what you're looking for, the object that is not moving. All right? If you're sitting on a park bench and you're watching a car go by, what could be the frame of reference?
Seat.
The seat that you're sitting on, the park bench. Okay? If you're sitting in your car and you're driving down the road, what could be the frame of reference?
Steering wheel.
You're in the car moving, so you can't pick you in the car. What could be the frame of reference?
Radio.
What's the thing?
You're sitting in the car driving down the road. What's the frame of reference? Except my hand's on my lap. I'm driving down the road. Okay? What could be my frame of reference?
Light pole.
There you go. Light pole. The stereo's in my car. My car's moving. I can't pick anything in my car.
No, they can get there outside. They can be like a concert or something else.
Oh, okay. So I'm past the concert on the side of the road.
And how can we
Highly
pick the
unlikely.
seats? How can we pick the seats of the bus? Because they wouldn't let them move.
Oh, yeah.
Okay, now if I'm on the bus, remember what I said to be the seats of
Only
the
if
bus.
you're like doing something.
We're in the bus, focused inside of the bus. Now, if I'm riding on the bus and I'm looking out of the bus because I'm nosy and I'm checking everything out the windows, I got to pick something outside of the bus. But if I'm focused inside the bus, let's say I'm playing cards and I'm only looking down at the aisle because I'm playing cards and I'm gambling illegally in the bus. Okay?
Yeah, Williams.
Whatever's going on in the bus, if I'm not focused outside of the bus, then something inside the bus can be the frame of reference. But if I'm looking out the windows, something outside of the bus has to be the frame of reference. Does that make sense?
Yeah.
So if I'm driving, I hope I'm looking out the windows. Okay? So if I'm looking out the windows, something outside has to be my frame of reference. Okay? My radio or stereo inside can't be my frame of reference. Okay? So I can pick the park bench, I can pick the pole, I can pick the statue downtown of, what is it, the police officer or the kid? I can't remember. All right? Give me whatever's on the town, the Christmas tree that goes up in December. All right? But it's got to be something else.
I thought when a park car they got mowing to do the car show.
Okay.
I thought it went up there.
It may. I have no idea. I'll never pay attention to it. All right. All right. What is motion? Okay. So in order to move, we have to change what? Change in. That's not what I want to do. That's not what I want to do. We have to change in I'm here,
Places.
position. Over.
Course of time.
There you go. Very good. Over time. In order to have motion, you have to change position over time. Okay? How do we know if an object is moving?
Stationary objects.
What do we call
Oh, that's a war.
it? Okay, we're going to abbreviate it. Y'all are big on abbreviations. All right? All right, you got to compare it to a frame of reference. I'll let you catch up because I know I didn't have to write that stuff down. Some of y'all are behind.
Now,
Hey, listening, no one tells them. The bills that they had yesterday.
you mean the ones before yesterday? Yeah, those yesterday.
We have a fire alarm. We have a fire alarm that goes today for this thing. So this things are like we're, they keep on the thing. And we're listening to everything.
All right, you caught up with me?
Yes.
All right. Before she comes back and I'm done. All right, so we need that. No. No, we don't need that. All right, this is what we want to finish with today. All right. Yes, you do. All right, so today and on Tuesday, we're going to learn how to calculate distance and displacement. Okay, distance. Distance means everything you had to go through. Every twist, turn, back up, and zigzag. All the mileage you added to the car's odometer from the start point to the end point. Okay? It's everything. Displacement does not work this way. Okay? It's very different. So basically, when we're doing distance, all you're going to have to do is add. There. Okay, so I know if my room is humid. You know it's humid when all the envelopes seal themselves. Best I can do. All right. You don't have to write this if you don't want to. All right. Now, distance is always greater than displacement. Okay. So when we calculate this, distance is going to be the bigger number. Okay. Now, do I need to wait? Okay. All right, distance is going to be our bigger number of the two. Distance will be bigger. Displacement is usually going to be our smaller number. Now, displacement, and some of what we're going to do on Tuesday is going to require you to use some math skills that you learned in, I'm guessing, Algebra 1 or Math 1. Okay? Don't worry about these weird drawings right here. Okay? I'll put in my pocket. Don't worry about that. Okay? Just the top. Displacement. Okay? Displacement is the difference between the starting point and the end point, regardless of what happened in between. Okay? So for displacement, we're only looking at where we start and where we end. Okay? We're looking at where we start and where we end. For distance, we're adding up everything. Okay? Distance adds up everything, and displacement is looking at the difference. Now, what does difference mean in math class? To subtract. So we're looking at where we start and where we end and the difference between them. Okay? Now, I often describe displacement as this is like taking a shortcut. Okay? So in a minute, we're going to talk about an example. And displacement is like the shortcut. All right, does everybody have what they need or what they want? All right, I don't want that yet. So, all right, so let's say that I drive 11 miles from Tyro to LSHS and then drive 11 miles home. Okay? We're going to calculate distance and we're going to calculate displacement. Distance and displacement. Now, distance is every mile I drove today or will drive today. How far did I drive coming to work today? And how far am I going to drive to go home today? So on my car, how many miles am I going to drive to go to and from work? 22 miles. So for the purposes of the gas that I'm going to burn in my car, I have to drive 22 miles to get to and from work, right? That's my distance. It's how far I have to drive my car to go to and from work. That's distance, okay? That's why I said distance back here in the definition was every zigzag, every backup, twist, turn, everything that my odometer measures. That's distance. Now, oh, good Lord, I'm at the end here instead of at the beginning of my extra pages. So, displacement. Displacement looks at where I stop and where I start. Okay? It doesn't care what I do in the middle. Where did I start? Where did I start at? I started in Tyro. Where am I stopping at? Home, which is in where? I start in Tyro. I stop in Tyro. So what is my displacement? Nothing. I start at Tyro. I stop in Tyro. My displacement is 0 miles because I went 11 miles to school and I turned around and did what? Went 11 miles back. So I essentially went 11 miles and 11 miles home, which is 0 miles. If I start at Tyro and I go back to Tyro, doesn't matter that I went to the store. I started and stopped in the same place. My displacement is 0. Okay? Now, the only way my displacement changes is if I don't start and stop in the same place. That's right. So if I start in Tyro and I come here and then I don't go back to Tyro, then my displacement changes. Okay? It would be something else. It wouldn't be 11 miles. I'd have to go someplace else. All right? Now, are you packed up? I got 5 minutes. Get your stuff back out, or you be staying with me 5 minutes during lunch. Aren't you in enough trouble from last night? Can you tell me something about an ejection? I swore you had that conversation. All right, so if we take Logan's example, okay, and let's just say that I drive, okay, 11 miles to LSHS from Tyro, and then I drive well, let's not say that. Let's say 21 miles to Moxville for the night. Okay? Pass down 64 to Moxville. Is my displacement going to be 0? No, because I drive 11 miles. Okay, I'm in Tyro. I drive 11 miles. Whoops, not 10. Dingy. 11 miles to LSHS. And then I turn around and do what? I drive 21 miles to Moxville.
So you take the big numbers, subtract 11.
So what do I have to do to figure out my displacement this time? I have to subtract.
So
21 minus 11 would be 10. So my displacement will be 10 miles. Now that's displacement. What will be my distance?
32.
Okay. My distance will be 11 plus 21, which is 32, because you always add for distance. Now, what do you suppose I want you to do this weekend? For your what? Now, you can do test corrections on any test. However, if you make a 40 and you do test corrections, the highest you can make is half back, which would be a 70, right? We would like to do well on the first test so that you start out with an average. Those of you who did not hand me a lab sheet, the only day I have next week is Wednesday. I have lunch every day. Every day you can stand and make up work. Did you hear me say that? Okay. I will be here Wednesday next week. I got staff meeting Tuesday. I got Central Office meeting on Thursday. But if you, and I never say Fridays. Fridays is a religious holiday in this Walls world. I don't cook. I don't clean. I don't do makeup work after school. Okay? It's Miss Wall's religion. There's no actual religion. I just don't say on Fridays. The 28-year veteran holiday. So, if you want to do work, I'm here. Do not take a 0 on that lab. Come finish it. Put my calculators in my tub. Have a wonderful 3-day holiday. Make sure I have my calculators. You too. Have a good birthday, Nathaniel. Oh, on my desk over there, you'll see a stack of them.